Hey guys, welcome to episode 2 of Engineering with Evan. Today we're going to connect the Arduino board to the red board, and we're going to do a bit of coding with our motors and getting them to move around. So yeah, let's get into this. Oh jeez. Okay, so I've got some resistors set up. So if this like fake Arduino board or bootleg Arduino board only takes in 3 or 5 volts. So I'm gonna do 5 volts just for now, or 3 volts for now. So how the math works is voltage output is equal to voltage input, so 12 volts times resistor 1 divided by, in parentheses, resistor 1 plus 2. So we know that we need a 1000 ohm resistor and then also a 330 ohm resistor, and then we get the amount of voltage we want. So let me hook this up here. Okay, now I can take this and hook it in, and hopefully this should work. Plugging it in. Why do I struggle plugging this thing in? Not that serious. Okay, there you go. You see the light on? The green light means it's on. Yeah, okay. So then we need to get the USB to our computer. So let me go grab that. Alright, so I have it connected to my computer, found a wire, and it's now flashing orange. I think that means it's connected. But I don't know what to do now, because now there's just nothing here. So, alright, I've made some progress. So I attached it to my computer, and I downloaded the Arduino app, and then I ran some code. So I have to learn C++. I thought it was in Python, but it's not. Anyways, so I was able to get it to connect. So there's a bunch of these pins here, and these are like output pins or whatever. And then right here is the ground. So I just attached those back to the board, and now I can change using my computer how fast it turns on and off. So for example, if I wanted to turn on and off every 50 milliseconds, it does this like that. And you can see it does it on this light here, but I connected it so that it also does it on this one here. Alright, I'm gonna try and attach it to the motor here instead. So this is our power. So this goes in the red here, and the white goes in the black. So if I turn this on, it should start moving this. Let's see. Okay. Let's see if this works. Oh, what? Oh, I think it's because there's not enough voltage. Yeah, because I don't have my good board. Okay. Scratch that then. Let's try with the other one then. Okay. And then turn it on. Oh jeez, that's not good. Look at that. So it turns on. Okay, let me try something. So if I take this, it freaks out. I wonder if it's because it's using so much voltage when it moves. As you can see the orange light down there, it's struggling. Huh. Alright, I'm gonna try something. Okay, so I have my motor here. I put this thing on because it's a shield, not an Arduino board. It's a good thing I have this. And I found out that these are not lights on top, they are screws. So I'm going, and you have to put your things in here, unscrew them, then rescrew them, and that's how you get them to work. So I'll be right back and just get my screwdriver. Got my screwdriver here. Just gonna open this up. Open this one up. Actually, I think this is the ground. I don't know how this works. Okay, so I've done a lot of work, and I've connected it to here. Got the motor connected. The problem is the motor won't work because I'm missing a shunt, or I forget, a jumper. I can't figure what it's called right here. And I don't know where it went, so I'm gonna have to buy a new one. I don't know if it even came with it, but that's really annoying. The code and everything's working. So yeah, I just gotta do that, I guess. Ugh.
Okay, so I feel like I didn't explain everything that well in the video that is coming up, so I'm going to try and explain it again. So an H-bridge is kind of like a mini circuit board that switches polarity. We know that electronics all run on ones and zeros, and my goal was for this motor to switch from positive to negative and turn off. So that is 3 inputs, not 2. That doesn't exist. You have on and off, an on, off, and something random, right? So this doesn't work. And I ended up like messing a lot of my shield up because of that. But I learned that there's such thing as an H-bridge, and I can use my Arduino board to, and with an H-bridge, to switch polarity. So the cool thing with an H-bridge is it takes that one input and uses that to switch a. So there's these two these two connectors that go to one motor, and this one will go to another motor. So the one will switch what side of the positive and the negative will be, which switches polarity. Polarity in a motor kind of chooses what direction it will go. So this will choose what direction it will go. So I'm only going to use one of these because I just want this to switch directions. I don't want 2 motors running at once, I only want one. And then the 0 would be the off, right? So I would need 2 pins from the Arduino for the off and the switching polarity. I'd also need a ground from the Arduino and from a power source. I need to put those together and put that into my H-bridge. I'd also need the positive power powering the H-bridge. The H-bridge can take up to 12 volts. I think more, actually, like 25 volts. And then it turns it down to about 5 volts. Something like that. 5 to 9, I think. So that's good. And then I have, yeah, so that's pretty much it.
Okay, so here's what we got. I have good news and some bad news. We don't need the shield anymore. There's some built-in H-bridges inside, but only 2, and we need 4 because we have 4 motors, right? So what we have now is we can just do straight to the H-bridge. So I'm gonna have to disconnect these just from the one and put it into this, which might be like a waste of a giant breadboard, but we just need to disperse the power into 4 quadrants. So when we use the power, we can just take it from one of those quadrants. We won't be running 2 motors at the same time, because that'd be too much work to to do. So anyways, here has how this circuit works. So we have our power, right? The red and the black is a 12 volt goes into, 12 volt goes into this one here, and then where the red is, and then the black is the ground, right? So these two right here is what would power our motor, and then this is where we put our, no, right here, sorry. This is, so this is our output, this is where we put our motor, and then these two pins here are your input, and this is where we put our Arduino inputs, right? So that's where we get our change in polarity. So right here is everything we have. We have the ground in our Arduino. So you hook that up to the same spot you hook up the Arduino, same spot where you have the power. Ground, power source is ground, so they're like in the same space, so they share the same ground. And then after that, we hook in the 9, which is our orange wire here, into input 1, and we hook in the green in input 2, and then that would change the polarity, and pretty much whether each of these go would change the polarity. And then we'll take right here is our motor's 2 wires, red and black. The red one would be input 1, and input 1 is here. So let's put that in. And then once I turn my computer on and turn the power on, we'll run everything, and it should make the motor go forward and backwards and stop. Okay. Nothing fell. You see that red light is on? That's showing that there's power going through it. A little bit of sparks, but that's okay. That's just because the red and the black wire are so close. You see the green light on, which means that's on. And then once I run this code, fronts and backwards. You can see if I put this on, goes that way and backwards. Boom. Just look at that. Isn't that satisfying? Only took me a week and then some. But we did it. So now I'm gonna try and set up all 4 motors and get them to go forward, stop, forward, stop, forward, stop, forward, stop, backward, stop, backward, stop, backward, stop, backward, stop. And we'll see you there when we get that. If anyone knows what these like yellow, white, blue, green wires do, please tell me in the comments. I honestly have no idea. And ChatGPT has not helped. Oh. Oh. Look. I need to put two things on it. Alright, sick. I'm gonna build something and attach the two to each other and see if I can make like an arm move. Right. See you guys in a sec. An arm, and that arm will move up and down. So yeah. Going right when it happens. Oh my gosh. Unplug it. Okay. Torque was a little too powerful. Look at that. So if we want to be more like exact, we'd have to measure and do some calculations, testing. Okay, so I'll print everything out, print out the 3 pieces so we can have our motor go spin like this, spin like that, and then like this for the flipping of the pancake. Yeah, so I'll get back to you and do that. Thanks, guys. All right, print is going. These are the designs. I'll get back to you guys tomorrow when this is done. I didn't put on the recording video software because I forgot, so I guess I'll do it for the other parts. But yeah, it's going, so I'll see you guys then. Alright, so this is what I put together. This does not work. I have to get a new thing here because the top is in wrong, and I don't know how, but it printed out like this really small and does not fit out the motor, so I have to reprint that, just remake this entirely. I also have to reprint these. I don't know how, but I just messed up. That's how. So anyways, that's what I have to fix. And then I also have to design the pump next. So yeah, I'll see you guys then. Okay, so I have an update I gotta show you guys. I probably should have recorded me doing this, but I didn't. This is what I have so far. I put pretty much everything into place. I don't have the second arm, right? But you can see the thing through here. But you might see some things are broken off. Some things are melted. And that's because I actually used a solderer to melt off a lot of plastic. And oh, can you focus, please? Focus, please. Focus, focus. Yeah, so the plastic here, I had to melt down PLA. Don't worry, I wear a mask and protection. But pretty much everything is melted down and everything was working. And I put everything in place. And then you might notice here that this kind of looks like, oh yeah, and this keeps happening. I have to fix this somehow. One sec. This piece has a really small slit here, and if I put this here, it won't fit, or nothing will be able to come out. No wires will be able to come out of that. Yeah, so I realized that and did fix it. But the reason why this is all gross is because I dropped the thing while working on it. It fell off the table and it snapped the piece off of the real version of this. So I had to melt it out because it was stuck in here, and now I have a pit and I need to reprint this. But everything else is working. I just need to get this to stop breaking because this is annoying the crap out of me. And yeah, everything else should be working fine. But like, for example, there's a lot of wires that need to fit through up here, and that is not gonna fit. That's too small. So I gotta redo that. And then I'll make the final arm. So let me show you my design for that. Okay, good thing this CAD software is because I cannot draw. But anyways, I'll try and show you my design. So this will be the arm. This will hook into the motor here. And then down here will be the connector part. I messed up here. It's gonna kind of come straight off from this, so it's gonna be kind of angled at 45 degrees and then straight. And then this would insert into this. This is the flipper I'll be using. And then up here, there's this huge arm piece that will come down. It'll kind of be like a base for the motor right here. And then there's this circle thing that will be spanned by the motor. And it'll be on the motor will be connected to axles. And the motor will spin this axle. And then it will push and pull the syringe, and then the syringe will puke out the pancake right next to this thing here, because the flipper here. Problem is I can't, like, the pancake maker will only be able to go like this. It won't be able to go like this. It'll only be able to go like this. So it has to be lined up perfectly for when it's fully down at a flat base. It can also shoot out pancake batter. So this tube right here will be the pancake batter. It'll kind of follow the arm back, and then you can just like aim it into a bowl, and then that should suck stuff through. Like tested before. I actually didn't test the tube part, but I think that'll work. It'll work good. Yeah, that's everything. Hey guys, this is the last point of the video. I'm putting together all my 3D prints. This part's really long, and it's just kind of me running around and going to the soldering machine, which is not on camera. So it's kind of boring, I'm not gonna lie, what's going on here. So I'm not gonna put you guys through this, watching me just kind of disappear, then come back, and disappear, come back. But I'll cut right to the end. But I had to do a lot of soldering and a lot of changing because there's a lot of pieces that didn't really fit. I'll get to at the end what I still need to fix. But thanks for sticking around, guys. Okay, final reveal of the episode. This is what it looks like.
This thing, you cannot lie, looks absolutely insane. So I think this is good now. I might have to do some tweaks next episode. I don't really know what I'd change. Maybe I might have to make a whole new one of these and just make this the piece that connects in longer. And then I'm gonna leave this out because it's bending the machine, or bending this and breaking this. So I'll leave that out for now. But I'll fix that. That's an easy fix, just to put that in there. But it's putting a lot of pressure on this, so I'm not gonna do it. Because of how much weight there is, it's like turning this, so that might be a problem. This might have to, I don't know what's the deal with that. We might have to change some stuff with that. But yeah, so next episode, we're gonna do wiring and tubing and coding, and the next episode that should be done. But yeah, that's robot arm. See you in the next one.